Hi, sir.
Hello, Haripriya. In the last class, we were actually studying this one, no? Hmm. Specific heat capacity and calorimetry. Okay. Acha, in this class, I'll be telling you about the phase change. Then we'll move on to the actual heat transfer and radiation. This part comes under the part that we have studied till now. It actually comes under calorimetry. See, the phases, we say, what are phases? Phase are three types: solid, liquid, and gas. Actually, till now, through calorimetry, we have actually understood when a liquid which is present in the same phase, it changes its temperature, then how we calculate the heat absorbed or heat lost. MC delta T, like that. But what happens if a body changes its phase? Like if it is present as solid, means take the case of ice, it's solid, it's at 0 degrees Celsius. Now it converts to liquid, means water, but still the temperature is same. So according to our calorimetry, there should not be any heat exchange because the temperature is same. But in this case, what happens? It is absorbing heat. Because of that heat absorption only, it is changing its phase from liquid to solid. Sorry, solid to liquid. Because actually at molecular level, what is happening, at molecular level, what is happening is the molecules are actually, they were actually well structured, means they were crystallized. Now when you have given heat, they have absorbed energy, they started moving, and then they broke the bonds, and then the bonds were weakened, so the solid has become liquid. So it absorbed energy, but what kind of energy it absorbed, that we actually have to calculate. And that heat, that energy that it has absorbed is given by latent heat. Q is equal to M into L, MLF, where M is the mass of this ice. Actually, mass is not being changed, it's remaining same. And LF is known as latent heat of fusion. And this heat is not dependent upon the temperature. Okay. Now what happens if we move further? The liquid, same mass, will rise its temperature to 100 degrees Celsius. Still it is liquid, water only. In this case, if you ask me, sir, how much heat it has absorbed, the heat it has absorbed is equal to mass M into C into 100 minus 0, MC delta T. Now again, what happened? From 100 degrees Celsius, it has changed. Temperature is same, but from liquid, it has converted into vapor, steam. Again, phase change is there. So it will again absorb the amount of heat which is known as latent heat of vaporization. It's MLV. Mass is same, where LV is known as latent heat of vaporization. But don't worry, this value, the latent heat of vaporization and latent heat of fusion, whenever it's asked in your question, it will be given. The value will be given in the question itself. So you need not have to worry. You need not have to memorize these values. Again, if the temperature is raised to 120 degrees Celsius, same mass, in the same steam phase only, the amount of heat that it will absorb will be equal to Q2 is equal to MC2, let's say it is C1, MC2 into 120 minus 100, like that. So what I was concerned means what I was trying to teach you through this, what is the amount of heat which is involved during the phase change from ice to water, from solid to liquid, or from the liquid to vapor. These two things. Clear? Mm, now try solving this easy question. It's not a difficult one, but just the basic one. I'll give you the options also. They are not given actually. Concepts are not given. Options are not given. 5 degrees Celsius, 6 degrees Celsius, 7 degrees Celsius, 8 degrees Celsius.
Sir, what's the specific heat of water?
Specific heat of water, it's not given. I think I have given you the last question also, no?
I have forgot.
4.18 into 10 power 3.
Sir, could you show the option? Sir, option A, 5
Hmm.
degrees Celsius.
It was easy, na?
Yes.
Hmm. You have to use. It is very easy. What about you, Kanishka? You did it. You have to just put like this: 50 into specific heat of copper 420. It's raised by temperature 10 degrees Celsius. That's equal to 10 gram of water into specific heat of water 4.1 10 per 3 418 0. अच्छा. You have approximated. Okay, you have approximated it. 41.8 into 10. And this you would have approximated as 42, right?
Yes.
Hmm. Because the options are given as such. See, this kind of approximation also you should do. What about you, Kanishka?
Yes, sir, I got it.
You
Sir,
got
I
it?
was just feeling headache, that's why like ठंडा लग गया मुझे थोड़ा सा
अच्छा,
बाकी
ठंडी लग रही है क्या? नहीं, अगर ज्यादा
हाँ
सिर दर्द हो रहा है तो रहने दो.
नहीं ज्यादा नहीं हो रहा सर अब तो ठीक है
कि
दिन में रेस्ट कर लिया था
सर्दी ज्यादा होने से ऐसा होता है, मतलब जैसे लेफ्ट साइड में पेन होता है या कभी राइट में होता है ऐसा. तो मैं तो वो जो बाम वगैरह होता है, कभी ऐसा होता है तो बाम वगैरह होता है ना, उससे थोड़ा सा हल्का हो जाता है. झंडू बाम वगैरह होता है ना, अल्ट्रा पावर.
यस
कॉमन है, हो जाता है. पता नहीं क्यों होता है ये. एक्चुअली मुझे लगता है कि ये होता है उसकी वजह से, सर्दी की वजह से जो हमारा जो नर्व सिस्टम है ना, उसमें गड़बड़ होती है. इसलिए बाम वगैरह जो होते हैं वो उसको रिलैक्स कर देते हैं नर्व सिस्टम को. सी, now coming to the next part. The next part is actually this is the actually interesting part, from where that the advanced level questions are framed. But I don't know why, but this JEE Main and JEE Advanced, they are actually still in JEE Advanced they ask the questions on this conduction, but in JEE Main they are not actually asking much questions on conduction. They actually focus on the radiation part. Conduction part is being focused in advance. But if you will take, but this is a very interesting portion, conduction. It's like current electricity, and you will compare it with current electricity for solving questions. Like we did now for fluid mechanics. I have given a part in which there was a this cylinder through which resistance we used to calculate Poiseuille's formula, compared that was compared with the resistance current electricity. In the same way we do for this conduction also. But why JEE Main, actually they are not focusing on asking questions from this. But when you will take mechanical engineering as your branch, there the whole topic is there on this heat transfer conduction, and many students actually skip and therefore they face difficulty there. But anyway, I know you will be taking computer science, so not to worry. So heat transfer is actually done through three processes: either through conduction, second one is convection, third one is radiation. Now what is conduction? Conduction is a way of heat transfer when heat transfers through bodily contact. Means when two bodies are in contact, or suppose we transfer heat from a solid body, then that process is known as the conduction. All right, heat transfer through solids. Now convection, what is convection? Convection is actually a process in which heat transfer takes place because of the change in density. How you have seen in your households, in your house, when mom cooks or something, boils something like water. If you boil water, boiling you also can do. That's not, I don't know, you are maybe cooking or something, you know, cooking or not, but when you will be boiling water now, you will see bubbles. What actually happens, the layer which is on the gas is being heated, the surface, the water level just above that is actually heated first. Its density gets lowered. When something is heated, its density decreases. Why? We see microscopically, when it's getting heated, molecules inside, they get energized, they try to move away, so the density decreases. Now when the density decreases, we know when two things are there, two liquids are there, one is of higher density, one is of lower density, the higher density liquid goes down. It's supposed to be considered heavier. Okay, so because the liquid, the water which is in contact with the lower surface which is being heated, the density of that lower water becomes low, it goes up. The upper is already having higher density, so it will come down. Like this, again, the water which has come down, that water will again get heated up, its density gets lower, it goes away, goes up. So like this, circulation of water takes place. In the same way, circulation of air also takes place. Because of this only actually rain happens. Whenever it's heated, means due to sun rays, the water gets heated. Water has a different property, that it has the very high specific heat. You have seen 420, 42, 41.8 into 10.3. It has very high specific heat capacity. Because, so what's the meaning of that? It can hold heat for a longer time. So the water is, you must have observed, means at hotter places the water tends to remain more hot for a long time. So the places which have water bodies have actually the normal temperature. They are not cold much, no dry weather. So what happens, the surface near to the water level which is hot, the air which is near to the water level which is hot gets lower density, so it takes away the water vapor which is present to up, because of density is lower. Then these water levels, when it rises to up, they become heavy because the temperature is again decreased at top. So these water vapors actually tend to fall down then. So it becomes, the raining process occurs. This I'm telling you in the natural, how in the natural process convection takes place. Radiation is a different thing. So convection is heat transfer through density difference. Now what is it? Radiation? It's the heat transfer through EM waves, electromagnetic waves. So the important question that can be formed in this is, radiation does not require any medium. For smaller examination, these kind of question can be asked. Now since you have understood what is conduction, what is convection, and what is radiation, let's go deeper. In the conduction, I have said the heat transfer is through the solid. So let's consider a solid body. Suppose the temperature here is T1, temperature here is T2, and let's say temperature T1 is greater than T2. The length of the solid is L. The cross section, just think it is like this. Like this. And the cross section area is A. Suppose here also, here also. So, and let's say there is a constant K. Now the heat is being transferred from this surface to this surface. In this, K is the heat conductivity. It's a constant. I'll say why it comes into picture. Now what they say, if Q is the heat which is passing through from one surface to the other surface, because there is a difference of temperature. Whenever there is a difference of temperature, heat will be transferred from one point to other point. So what they say, this dq by dt means rate of heat transfer, or you can write it as q by t also, is proportional to difference of temperature. Okay, this was the law. Now when they have removed this proportionality constant, dq by dt they have written as Ka into T1 minus T2 divided by L, where L is the length along which the heat is being transferred. How you will see, because in many questions you will find difficulty in understanding which length we have to take, either this one or the height. So just look at the problem, just look between what two surfaces the temperature difference is there. So the temperature difference is there, so heat will be transferred from higher temperature to the lower temperature. And now in the direction of heat transfer, the length which is present, that length you have to take here. A is the cross-sectional area which is perpendicular to the heat transfer. Understood? This is the law. Understood, Haripriya, Kanishka?
Yes, sir.
Okay. Now see. Now when we are actually solving questions, what we do, we actually write this we treat this Q or dq as charge. So dq by dt will be current. And this temperature difference T1 minus T2 delta T is treated as delta V, voltage difference, when I'm comparing this with current electricity. In that case, this dq by dt, which is I, thermal current we say, is equal to T1 minus T2 divided by L by Ka, delta T by L by Ka. that can be compared as delta V by R TH. So when we compare this equation, dq by dt is equal to T1 minus T2 by L, K into T1 minus T2 by L, dq by dt becomes current I, T1 minus T2 is delta V, voltage difference, so L by K becomes R, resistance. So we can actually solve these problems considering them as current, the current electricity. This is I, this is R, the voltage difference is delta V. I is equal to delta V by R, where delta V is delta T, T1 minus T2. R is L by Ka. I is dq by dt. Understood this one? This is very important. Tell me, Kanishka, okay? Haripriya, okay? Do you want to process it?
Yes, sir, it's okay.
It's okay ना? Kanishka, okay ना? अच्छा कनिष्का का सिर में दर्द हो रहा है? Okay, no problem.
Yes, sir.
Now let me give you some questions on this. Try solving this one. What happened? Could not solve it?
Sir, I'm getting 10 degrees Celsius. But
No, the answer is wrong. They are saying it is 2.
they're like,
See, let me show you. Because it's first question, na? Let me show you how it's solved. Heat is flowing through a rod of length L, means the rod is given to be of length 50 centimeter. Area of cross section is also there. A is equal to 5 centimeters square. Ends are respectively 125 and 25 degrees Celsius. K is given 0.92 kilocalorie. You have to convert calories into joule, na? Let's see. Temperature gradient. Oh, acha, 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 acha. Okay. See, the formula is delta Q by delta T, dQ by dt is equal to what? K into delta T by L. No, but see, Q is not given. But Q I can write here as ms delta T. So dQ I can write as ms delta T. So it will become ms delta T by dt is equal to Ka into delta T by L. But this value they have given as K, they have given as ms delta T by delta T. K is 0.092 by ms. And for 3 we have to convert this calorie into this. Or we can direct 4.18 na. 1 calorie is equal to 4.18 joule. Area. What is area? 5. 5 into 10 power minus 4. Length is 50. 50 into 10 power minus 1. Delta T. Achha. Temperature difference is given 125 and 25. It's 100. This is temperature gradient. What is this? MS is not getting cancelled. Check this again. We need to calculate, do we need to solve like this? Because they have asked temperature gradient of the rod now. And temperature gradient is not delta T by delta T. It's delta temperature difference divided per length. No, it's not at all needed. This way it is not needed to solve. We are unnecessarily complicating things. Mass is also not given. Na? The temperature gradient will be simple, this one. Delta T by length L. This is the temperature gradient. So 125 minus 25 by L. 50 centimeter. 100 by 50. 2. Simple.
We didn't even want the formula.
We did not have to use this formula also. That's what I was thinking, because when I was applying the formula, na, actually MS was not getting cancelled. That's why there was some problem. Acha, now try to solve this one. This question will be using the concept.
Sir, I'm getting A.
A, you are getting. Correct. This was easy question, no?
Yes.
Rate of heat loss is same. In the first one, it will be K1A1 into both having temperature T1 minus T2 at the ends. Length is same. This will also be equal to K2A2 into T1 minus T2 by L. L gets cancelled. This gets cancelled. So K1A1 is equal to K2A2. Simple question. This is even somewhat difficult one. Acha. Let me give you a better one. Better question. Try to do this.
So option C, pi is to 2.
No, they're saying 2 by pi.
2 is to pi.
2 is to pi.
Yes, sir, I've taken the opposite. Have taken straight as first and then semicircular.
See, actually, correct. Actually, this is cross section area is same, na? Only the length is different.
It depends on the length.
The temperature of the ends are also same. So actually, dq rate of heat transfer dq by dt is actually inversely proportional to the Ka to delta T by L. Is it inversely proportional to the length? So Q1 by Q2, if you want, it will be equal to L2 by L1. Straight rod is straight rod length will be 2r, and it will be pi r, 2 by pi. This length will be 2r because radius, if we assume 2r as the radius, this length will be pi r. That's why. The combination of series and parallel teach in the next class. Let me give you some more question to you. Try to solve this question. This was asked in JEE. Try this. Question did not come. Try solving this question. This is interesting one. See, the concept that you should apply here is, if suppose the temperature of this point is T, Q1 is the heat, Q is the heat passing through from this left end to this. Some of this heat will be transferred to this right upper limb, and the other heat will be transferred to the lower limb. but Q will be equal to Q1 plus Q2 because it works like current. Because I have represented dq by dt as current. So I is equal to I1 plus I2. I can write total incoming is total outgoing current. So I can write actually dq by dt is equal to dq1 by dt plus dq2 by dt, like that. Or I can write this as q is equal to q1 plus q2, taking d by dt as cancel. That's why I have written q is equal to q1 plus q2. You have to do like current. Okay, this is a major concept using which you will be solving. Now solve it. It's easy for you, but it was as in JEE Advanced 2001.
So 45.
45. No, they're saying it is 60. Why? Same length, na? If we move from this dq by dt, 0 minus t by they are same, na? Ka into 0 minus t by L is equal to Ka into t minus 90 by L plus Ka into t minus 90 by L. This you can cancel out. Minus t is equal to t 2t minus 180. dt is equal to 180. So t I am getting as 160 degrees Celsius, correct only. Why you are getting 20? What was your answer? 20?
No, sir, I said 45. Only considered Q1.
Why?
I don't know. I just considered only Q1. I didn't consider.
You have to consider all, no? That's why I've told this one, this concept. Like current. This one you understood, now what I did? Okay, Haribhai, you understood now? What about Kanishka?
Yes.
So like these kinds of questions will be asked to you. Some 1 or 2 questions I'll tell you in the next class, and then we'll move on to the more complicated portion of this, series and parallel. When conductions are being done in series and parallel, like current electricity. Okay, let's end it.